that's fine. All right, now it looks like I'm in the bunker. Fine.
All right, you can hear me fine. Your lighting is much better. I'm not going to waste any more time trying to get this camera to work on my phone. So let's just get straight to it, Jonathan. Thanks for taking the time to do this. We're excited about the Powerball 2.0. Let's give some people a quick background. I want to talk as little as possible so I don't take up your time to present this stuff. I just want to remind everyone what the Powerball did for full arches is pretty revolutionary. A lot of us were struggling with manufacturing frameworks and zirconia hybrids and things that would fit to tie base, and then you'd seat that restoration in the patient's mouth. And as you have pointed out over the years, that's one of the weakest links in the whole system, is when the tie base meets the multi-unit abutment, and that's where the most prone, the weakness spot is in the hybrid, and it's where it's most prone to fracture. And you decided to ultimately take the risk of removing tie bases from the equation and milling straight to the multi-unit abutment. This is for the people who are not part of your group already. I'm looking at all the names in the attendee list, and I don't know how many of them have attended your courses, but that's a synopsis of where we stand today. So if you don't mind addressing that real quick, and then let us know how you improved and what you've done with the Powerball 2.0 screws.
Cool. So I am super happy that we are able to be here together tonight. But more importantly, not all of you are here yet. So we're recording this and we'll post it on YouTube to be available to everyone. But just a quick background for those of you that do know me or don't know me. If you do know me, you know who I am. If you don't know me, you have no idea who I really am. But essentially, I'm a dentist that practices in Hawthorne, New Jersey. I basically do 95% of my practice is implant dentistry. I'm blessed enough to be able to do the surgery, the restorative, and the lab portion of the cases. And because of that, of the ability to do all those things, I started to see that a lot of what we were doing was just extremely flawed. And I think the biggest reason in dentistry, Armin, you'll probably agree, is I think the reason we have so many issues is because we just cannot communicate with each other. The laboratory speaks one language, the dentist speaks one language, the corporate world speaks one language, and a dentist speaks one language. And I think that Cadre was probably, between Cadre and I say my company, we've probably proven that when a dentist comes into that world of laboratory, or world of instruments, or world of machines, we're able to all of a sudden start thinking like, what do we really need? And when we have the ability to say, hey, this is what we need, this is the solutions that we have, and if you can't make it for us, we will make it. And say Cadre, one of the biggest things we always had was support. They sold us the machine, but then nobody ever told us how to teach it. And I think a big platform in terms of what your company stands for is really what the support and the education that you're able to give to the users when they buy milling machines, scanners, printers from you, that a lot of the companies just don't have, or they haven't learned. This is why you guys are one of the fastest growing companies in the world. I will show you that what I've done with my screw, and more importantly, my whole system, has revolutionized dentistry. And I don't use the word revolutionize easily or simply. It really has. And I can tell you day in and day out, I get emails, text messages, direct messages from people that said, oh my God, finally we have something that's just saving us. And it comes not only from the laboratory standpoint, but also from the dentist standpoint. So I'll show you some of the parts that I've invented and stuff like that made us be able to do dentistry much better. And when you think about it, what the current state, unfortunately, is still in dentistry is the people that are out there lecturing are just, it's time for them to retire. Like, I'm tired of seeing the same case over and over and over and over. Like, if you're not practicing at the level that we're practicing, with the amount of volume, with the amount of stress, with the amount of restrictions that we have, it's very easy to be able to practice on an island by yourself and say, well, I used every single part, every single gadget, every single regenerative material to be able to create this beautiful one case that took me 10 years to actually do. But that's not real. The the industry is looking for people that go in and out. We practice. We go through the same issues that you go through and the same failures. And that's really the most important. You know, I was so tired of going to CE my whole career and never seeing a failure and just saying, man, these people are just so good and I'm just so bad. But in reality, you know, you do one case, it'll always do well. One case a year, you're screwing up that case, you probably shouldn't be practicing. But when you do a lot of volume and you're able to deal with patients that require so much, you know, it's a different game. And that's why it was time to really revolutionize the way we did things. The parts that we had in terms of implant dentistry, they were not invented by dentists. And if they were designed years and years and years ago to just say, hey, we have a part. There's no thinking that goes into it. There's no innovation that goes into it. It's just a part. Take it or leave it. Pay whatever I tell you to pay. You'll get it overnight. If you buy 5,000 of them, you'll get a deal. But that's just the way it was. The workflows, the word workflow, just really didn't exist. I think I was one of the first ones that brought this in. People use this digital workflow. What is a digital workflow? What is a workflow? You know, dentists know how to they have to get to the end. They have no clue how to do it. That's why on Monday they do it one way. On Tuesday they do it another way. On Thursday they do it another way. And they wonder, why is it that it works sometimes and it doesn't work another time? Because we just don't have a workflow. Unless it was a filling and you drilled, filled, and built, you really had no idea what you were doing. And when it came to computers and digital dentistry, we were able to actually make it systematically to say, hey, if you want to create a code, you want to be able to say, I'm going to go from A to B. You can't just randomly enter something and expect it to say B. You can't expect to do the exact same thing and get a different result. You're going to get the same result, and that's the beautiful thing about digital dentistry. So we create these workflows. But the problem really was the reason, you know, digital dentistry isn't new. Digital dentistry has been happening for years, 30, 40 years, but there was no workflow. There was no technology. It was just what we had, and we pieced it together, and that's it. But when we were able to create what I call a workflow, A to B to C to D, or what I tell my students, every single time you enter it into the calculator, 1 + 1, it will always say 2. And you take what we call the art out of dentistry in terms of that it's not always predictable, and we make it more and more a science. And that's really was the thing. And anytime you used to buy a machine, they used to tell you, hey, it's so fast, it's so good, you'll be so rich, you'll be so happy, it will fix everything in your life. And then you bought it because it was so shiny and you got a great financing deal on it, and you're like, wow, you bought it, it was all fake. But you still had that note, and you had to pay for it, and you had to figure out how to make it through. There was a lack of a full system. Whenever you wanted to do something, you had to go one here, one there, and it was very hard to integrate everything. And really now, the industry has now decided that no more of this going back and forth. And I hope that this is the pattern that's happening for us in our future, where everything will be sort of standardized and you have to go through back and forth, so that we can have more of an understanding and uniformity. So when we talk about these workflows or dentistry, what was the really problem? What was it? Like I said, we had no workflow. We had no steps that were predictable, sustainable, and repeatable. It just was not there. We were able to always constantly innovate. And that's really, in terms of my process that I've invented called the Excel implant process, I constantly innovate. And I always get these questions when I tell people, hey, I got Powerball 2.0. And they say to me, well, what was wrong with 1.0? And that's the way we sort of think. That would be like Henry Ford saying, T1 was great. Why should I do the new? Why should I make a car new? Or Elon Musk saying, you know what? I'm not going to make an amazing car. I'm not going to make a car that's faster, better. I already made one. It was the Tesla Roadster. It was based off of a Lotus car. Why should I do anything else? You constantly have to innovate. And if you accept status quo, you will be left behind. You just cannot do that. And I think your patients, I wouldn't say I think, I know that your patients expect you to constantly innovate, but not just innovate and invent and try it out on them, but most importantly, invent or better yourself so that every single time that you do something, you're giving your patient the best dentistry that's available. And really, I think that this workflow is alone in the industry in a sense that it doesn't require much, but it's repeatable, predictable, and sustainable. And it has just so many people behind it that are able to show their cases that were predictable. So what is the Excel implant process? Let me show you a quick video so you can see it and you can stop hearing me ramble.
Jonathan, there's no sound coming from your video.
Oh, interesting. How would I share the sound? All right, well, you don't have to listen to my mug. I'll just continue. How's that? Can we continue hear me now or not?
Yes, we can hear you.
Okay, let's continue. So what makes this Excel implant process possible? So people always tell me, hey, Powerball screw, Powerball screw, Powerball screw, but it's really not only the Powerball screw is like I would say like 10% of it. It's a whole full system that I created to be able to make everything perfect. And that starts from the pre-op workup. How were you able to take a patient that could be a dentulous, a patient that could have a collapsed vertical, a patient that could have no vertical, a patient that has incorrect dentistry done, or just failing dentistry. How do we take them from just taking a scan and 2 photos all the way to be ready the day of surgery? How do we decide that, you know what, I don't want to spend $40,000 on a photogrammetry that, as you guys know, I'm very against because it just creates too many errors. And I think that when photogrammetry will be able to scan not only the implant position, but also the tooth position and the bite position will be a game changer. But until then, it's just a positioner scan. And you still have to bring all these other things, and it just takes too long. So I've invented something called the THS gap. The THS gap is a temporary abutment. It's a healing abutment and a scan body. It's the only scan body that's patented in the industry that has different cuff heights. So you will never have a scan body that's too tall. You will never have a scan body that's too short. And more importantly, it's invented to create hemostasis. So you are able to scan the day of surgery, temporize the day of surgery, all with the same part. And this workflow that we now use, where we scan the day of surgery, deliver a prosthesis the same day, and then the prototype about a week or 2 weeks later, is just so easy. I don't understand why anybody would use anything else. You know, my original JA scan bodies were invented to be able to finally treat implants like teeth, and we're able to use intraoral. Again, this is all with an intraoral scanner. It was the ability to scan implants exactly like they were teeth and create the accuracy that we have with teeth, but also with implants. The power track screw allowed us in cases where we have the massive cantilevers of 2, 3, 4 teeth, and we would have to have distortion in our scan. I invented this screw called the power track screw that fits on top of my scan bodies that allows us to go from point A to point B to point C to point D and still never have a distortion because it's a real track for the scanner to continue. We then invented in milling templates. We've worked really hard with different distributors to be able to say, hey, once my designer designs this, make sure that my machine can actually produce it. And it can produce it predictably, accurately, so that when my prosthesis goes in, it's fully passive. And remember, when you buy and use this system, whether it's any tie-based list system, if your templates are incorrect, if your machine is not calibrated correctly, everything that you've done before is worth nothing. And if you jump into the system or doing these things, and just because you have a lot of money in your pocket and you can buy a scanner and you can buy a mill and you can buy a printer, but you have no idea how these things works, you're not only cheating yourself, but you're cheating your patients. So get the education to learn about how these things work and what it is that is important. And then finally, the Powerball screw. The Powerball screw, it created, came into the industry for something that had failed 20 years before. You know, if you guys know the Nobel Procera, it's not new to skip the tie base. It's just always failed. And I wanted to understand, why is it that we have now decided that a zirconia material that is extremely brittle, that is extremely prone to flexural fracture, why is it that we are now putting a bigger hole in it, putting some cement and putting a random tie base with a really bad screw that 3 to 4 years down the line, we're always either debond, break, or strip? Why are we doing this? And that's why I invented the Powerball screw. And on top of that, I learned that, you know, these 1.2 millimeter heads that the companies keep designing, why are we using that? It's the worst. You torque it once, you deform the screw, and you can max torque it to 15. You torque it to 20, you're done. So we invented a new screw that allows us to change the angle, to never strip and really put as much torque as we want or need onto this screw. So again, on the left-hand side is what we call Powerball screw 1.0. The middle is our power track screw, and all the way to the right is the JA scan body. Again, the JA scan body is the one that's rotating. This is the one that allows us to scan teeth, scan implants as if they were teeth. The THS is I would say, maybe the 2.0 version of this that allows us to have different scan bodies that have different cuff heights, so we always scan it correctly. So you can see on the upper right, this is part of the power track screw. We are able to make it faster, better, and just so much easier. To be able to do a case, especially when we sedate these patients that are really not healthy, instead of spending 6 to 8 hours with your guides and your reductions and your pre-planned stuff and the $5,000 bill that you've done, why are you doing this to yourself? It should be a 2-hour case per arch, no matter how good or bad you are. It is predictable. It is a workflow. Go from A to B. Stop wasting your patient's money. Stop wasting your time. Stop doing this to yourself. Have fun and do it predictably and do it easily. So I can talk here and I can be a great talker and I can listen and I can convince you of anything, but that's really not the point. I need to show you proof that my solution works. And I could show you X-ray after X-ray after X-ray where this works at 100%. If you dot your I and cross your T's, this will always work. You will always have a passive restoration. You will always have a restoration that has the correct occlusion, that has the correct midline, that has the correct aesthetics, and everything is checked off. And if you skip one thing, it will go wrong. This is not like, here's the impression, do your best. The computer doesn't work that way. It's not a technician trying to pay its bill. The computer turns on and turns off. It says 1 + 1 will always say equal 2. And that's truly important. So I can show you these x-rays over and over and over, but it really doesn't matter. So 1.0, what did it do? What did it do? It revolutionized implant dentistry. It made the full arch tie base dead. It's just, when I see a case that somebody posts with a tie base, you are living in the antiquated world and you have not educated yourself. A buccal access hole, and I'm talking about buccal access hole that's not just coming out of the gingiva. I'm talking about a buccal access hole that's coming out of the center of the central incisor or the canine. I don't care how good you are with composite. This will leak and it will not look good. You have strip screws. You should not have zirconia fracture as much as you had with tie bases. And you should have always precise passive fit restoration with this screw. Bacterial colonization that you have around your acrylics or around your tie bases, your restoration should not look like this if you take them off. They should look clean because polished zirconia, even subgingivally, can have tissue attachment. Why would you do this to yourself? Why would you do this to your patient? Why would you use something antiquated just because you read it in Contemporary Implant Dentistry version 1? It's time to learn. It's time to innovate. It's time to say, what we're doing is not right. Let's make it better. Stop being cheap. Stop saying, oh, my screw is $35. I got my whole green jackets and we're only paying $9 or $12 and we have this screw and it's the same. It's not the same. It's not designed for this. This is a screw that's designed for titanium. It's designed for tie bases. It may be designed for bars. It is not the same screw. It does not act the same. Do not do this for your patient. Do the best for your patient. And at the end of the day, the Powerball screw was designed with the doctor in mind. The templates that we mill were tried and tested for hours and hours and hours that I spent to be able to make sure that's perfect. And I made sure that the library was not corrupted. The library had different versions for different doctors and different milling machines and different printers so that it will always work. There is nothing in the industry that has that allows it to have every single doctor with all of the inconsistencies within companies to be able to still mill and print this restoration that it will always fit. So when you ask yourself, well, how many screws have you done? I remember the first day that I presented this, I think it was Dr. Graves said to me, well, Jonathan, how many have you done? I said, I don't know, I think I did 100 screws, maybe 75 screws. And they were like, okay. So 2021, I came out with this in 2020. In 2021, we sold 6,315 multi-unit screws, and the Medensi-based Powerball screw only sold 188. It's just not it's not a very popular multi-unit. And remember, this is not including my own cases. This is just what we tracked. 6,000 screws in 2021, no marketing, no nothing, just word of mouth advertising. 2022 to date, I've sold over 20,000 screws. There are 20,000 screws in function. They do not break. We'll go over why they break or how they break, but they really don't. If you follow the workflow, if you are meticulous in what you do, you should have no problem. Again, Medenti base is not that much in 2022, but this is becoming the standard of the screw. So again, somebody said to me, why am I going to innovate if it's not broke? So with what was Powerball 1.0? Powerball 1.0 was designed to torque at 20 Newton centimeters. That's it. That was the maximum torque that you should do. You didn't do more. You didn't need more. We just weren't sure what it's going to do in terms of the position on the zirconia and inside the multi-unit. One of the things we see specifically with the new PMMAs and even more the printed flexible resins, when we used to torque these screws in with no tie bases, right, the Powerball screw, we used to torque them to 20. We used to go out, do a hygiene check, come back, and the screw was at 5 or 6 or 7. And what we were finding was the resin was just flexing and then flexing back and causing the screw or some sort of deformation to the resin, and the screw was now loose. So we were seeing more screw loosening in PMMA and resin if we weren't careful about how we torqued it and allowed the resin to flex and rebound and then retorque it back to where it was. So we wanted to have something that had less rebound in PMMA or resin. We wanted to see that, you know what, sometimes when we milled these things, if maybe the channel was too long or if the machine wasn't calibrated, you would put the screw inside the restoration and it wouldn't reach. So I wanted to create something where I would have more, even if my screw did not reach all the way down to the multi-unit, say it didn't screw like 3 or 4 threads into the multi-unit, only screwed in 1 or 2, I wanted something that's still not going to break and not going to get loose. I also wanted something that we know that when we mill an angled screw channel, sometimes the seat of the Powerball may be a little bit over milled because of the way that we have it set up. So it is possible that in an angled screw channel, especially with a deep restoration, and I'm talking 25 millimeter restoration, that the seat wasn't milled exactly correctly if we weren't meticulous. So the screw didn't fully sit into the Powerball seat, and we were more likely to have screw loosening. I also wanted to make sure that even though that at the shaft of the area, which is right here in the Powerball screw, that takes most of the brunt of the force during occlusal forces, I wanted to make sure that there was no bacterial leakage that's coming up from here. I wanted to make sure that it was fitting exactly the way it was. So I innovated, I invented, and I created Powerball 2.0. So have I done cases? So this time I did something a little bit different. I created what's called an alpha group. I took 5 or 6 of the top Powerball users in the world, and I said, go ahead, use Powerball 2.0. What do you think? What should I change? Now, I don't know if they're afraid of me. I don't know if they don't care, but they all loved it. So I didn't change anything. But Powerball 2.0, over and over and over. And this is what I use exclusively in my practice now. And whether it's for an FP1 restoration, whether it's for an SRA abutment on Straumann flat zirconias, zygomas, it's the same thing. It works. It fits. And these are some of the cases that we've done. This is another FP1 case after a patient had a massive trauma to this front tooth, this front arch. We were able to restore everything on the upper, again, Powerball 2.0. Here's another case I wanted to just show you how thin we can do. Even imagine if you showed people back in the 80s that did zygomatic implants and you showed them a restoration that was this thin, mesial buccolingually, they wouldn't believe you. If you had access holes that came out in the center of the tooth and not palatal, they wouldn't believe you. But this is the standard today. There's no more long, bulky restorations. There's just no reason for it because they are very, very strong. PMMA. We now no longer worry about screw loosening in PMMA because of the way Powerball 2.0 is now designed. Zirconia, again, double arches, single arches, they always fit. We don't have to remake this. They always fit. Give me 1 second. Here we go. So if you can actually see, the screw is obviously patented. What did I change in the screw? The screw head is exactly the same. The amount of threads is exactly the same. But what I did was I added what's called the double retentive feature. The screw can operate as two different screws. It can operate exactly as Powerball 1.0. So you would torque it to 20 Newton centimeters and it would exactly act as if it was 1.0. Now, if you want to engage the 2.0 features, you now go to 25 and you can actually feel the double retentive feature of the conical seal now creating. I want you to keep in mind, okay? My friend Dan Rosen has a conical screw. This is not the same thing. This screw, the Powerball head, which you see right here, will seat first. And because of the extra threads that we have here, the threads don't always fully engage. We add 2 or 3 extra threads for milling errors. But again, this is a conical seal, and it's only after that the Powerball head is seated on its seat and you increase the torque to 25 Newton centimeters is when you will actually have that double retentive feature. So now, you now have the retention of the Powerball head, right, engaging and clamping down on the restoration. And then when you want to actually create more, you have the conical seal of 5 degrees on each side, boom, going into the Powerball screw head. And it does not engage the whole thing. It only engages right here, right below the Powerball head is where you go. In terms of the colors, the multi-unit is now blue, and the Medenti base is now titanium silver or light blue, depending on the version that you're getting. If you remember Powerball Screw 1.0, the Medenti bases was pink and the multi-unit was gold. The 2.0s are now blue. And if you want to get a closer look of what it looks like, still has the biaxial head, still has the rounded Powerball seat, but it just has that extra feature if you'd like to be able to engage it to 25 Newton centimeters. Just a quick look at what the actual cross-section looks like. Everything is the same. Again, the library is different. You have to have a Powerball 2.0 library. The milling templates are different. You have to have the Powerball 2.0 milling templates. And this is what the cross-section looks like. So just below the Powerball head is where it engages. Just this maybe 1 or 2 millimeters is where it engages. So there's no, it does not go ahead and attack the part of the zirconia that's thinnest. It does not wedge it as other screws may wedge. It actually just creates an extra retention where the Powerball screw head. Again, it's at 5 degrees just right here. This part is not engaged. This bottom part of the shaft is still to take on all the forces from the occlusal, side by side of the original 1.0 as opposed to the 2.0. This is just a quick look at how it looks like when it's milling. We worked really, really hard to make sure that the Powerball seat is milled one way and the other part is milled that way. If you are using the 1.0 template, you will actually over mill and you will actually use the screw as if it was a Powerball 0.0. It just won't work correctly. You have to make sure that you use the template. The beautiful thing that's happening now from Hyperdent is you will no longer have to do a second step to mill an angled screw channel. They are creating something called the implant module that will have Powerball Boom embedded, and it will take the library that I've provided for them and automatically replace it, and it will always mill perfectly. You will no longer have a mismill. In terms of the cost, the 1.0 will stay at $35 and the 2.0 will go to $39. And that is it. Any questions?
Let's see. Can you hear me okay?
Yes, I can.
Let's see if anyone's got any questions here. I have one for you while I try and figure this out. Jonathan, how many people do you think in the US do more than restorative part, more than 50 arches a year? What would you guess the number of clinicians that place more than 50 a year?
Well, you know, what's happening in implant dentistry is the single clinician, I would say like someone like me, is disappearing. It just doesn't exist anymore. And what happens is that private equity is buying up these type of practices. Their marketing is just so powerful. Now the question is you have to say how many screws are they using? I have centers that are using 500 screws a month. So how many dentists? You have to tell me how many implant dentists are actually working. I would say a typical general dentist that's doing this maybe does 1 or 2 arches a year. Someone who's good probably does 5 arches a month. Someone who's great probably does 10. Someone who's amazing and is probably charging very little can do 20 to 30 a month. So, you know, do the math. Depends on how many implants they place, right?
Yep. Yeah, a lot of
But this is
multi-centers.
the future. You know, people have found out that implant dentistry is actually much easier than general dentistry. And if you actually take the time, you know, you take my online course, you can watch some of these things at the powerballscrew.com, which is where you buy these things. If you educate yourself, you can like legit catapult your practice. And if you don't, you say, oh, I don't have time, then you're leaving all of this on the table. And it's really not about the money that you're leaving on the table. But there are so many people that need your help. They just do. But they don't want the help of an open tray scan body. They don't want the help of the denture conversion, or let alone the haphazard way of taking a person from dentate to edentulous to an implant restoration, where you take out the teeth, you wait 6 months, place the implants, you wait 6 months, you restore it, do 17 appointments. It just does not exist. And then you do all of this stuff, and then the tie base debonds. Or you do all of this stuff, and then the restoration breaks in 3 months. You have to create safeguards to make sure your restoration is the best it could be.
Ooh, we got a question from James Thomas Sierra. Do you have to purchase a Powerball driver, and the same for 1.0 and the 2.0? You already answered that's the same head, it's the same driver, right?
Same head. Yep, everything's the same in the top, yeah. Well, yeah, I said, you know, some of the problems in the industry is that it's not uniform. Why would I create a new device, a new driver? Oh, that's a Nobel BioCare thing. One driver, one screw, that's it.
Okay. Dr. Augenbaum is asking, is have trouble scanning the lower arch with the THS caps, same day of surgery, uppers no issue, any advice?
The biggest advice I would say is, remember, in the mandible, there's 2 things that happen in the mandible. First thing in the mandible is you have to look at your tissue. If you have a ton of tissue, then you know you're going to need the THS cap to really clamp down. I would say the most important thing that I do for the mandible that's important, because the tissue is so reflective, is I use powder. You know, there was this big thing, like, I don't want to use, once blue cam came, like disappeared and omnicam showed up, it's like, I don't use powder. Well, it's still a light. It still reflects. And if you're scanning something that's reflective, it's just not going to work. So even if you have blood on the tissue, you can still add powder and you'll scan much faster. Remember, the scan should be 1 minute. The other thing is that if you don't have a lot of tissue and you're not that good at scanning yet, then use JA scan body and power track screw. We have THS power track screws that came out also, so you can try that to help you out. But between power track, understanding how to scan, hemostasis, obviously, listen, if you don't know how to suture, right, and it's bleeding like crazy, then you're not, even if it's bleeding, that means it's super inflamed. That means that even if you scan him, the tissue is going to change so much, then why scan him that day? Just temporize him in the way that I temporize them and come back in 3 weeks. But I can tell you right now, I have never had a case at the day of surgery where I've had a THS cap on top that I wasn't able to scan. It didn't exist.
Not to intervene or interject, Jonathan, but immobile tissue is always easier to scan. So if there's any movement to the tissue, if you're pulling on the lip and your suture is not tight enough and you displace any of the tissue, you can distract the scanner. Dr. Gibbons is asking
100%.
about Trios 5. What are your thoughts?
Next question.
Wait, you started this whole thing by saying you got to constantly innovate and improve. You brought out the 14
To be honest with you, I mean, I can tell you, it's how can I, one of the things that I hate is that when you ask a lecturer a question and they don't know what the hell you're talking about, they just give you an answer just because they feel the need. Have I seen the pictures? Yeah. Do I think it's cool that you never have to calibrate? Yeah. Do I think that something called smart scanning is going to be a game changer? Yeah. But do I think it could be all fake? Maybe. So how can I stand up here or sit here 9 o'clock at night and tell you something that I don't know? I know that Trios products are always, 3Shape products are one of my favorite products. I think it's an amazing scanner. I still use Trios 3 wireless, Trios 4 wireless, and I don't see any difference. But remember, don't just spend your money. Find a problem and then look for the solution. Do not buy a solution and then look for the problem. If your 4 is working, keep using the 4. It's fast. I can't move my hand fast enough. So if you don't have a scanner, or if you're looking for a second scanner, and at 26,000, 28,000, I think with Cadre, I mean, it's a great deal. Like, I bought my first scanner. I think I paid 44,000 from Henry Schein. I didn't get a computer, I didn't get anything, let alone support, to learn everything on my own. So it's amazing how thing has changed. So if you're looking for a second scanner, hells yeah, do it. Looks cool. And it's a 3-shape product. It's not like random. It's not someone that decided they're going to make a scanner today. Yeah, look into it. Educate yourself. But I don't have my hands on one. And you can be sure that the second I get my hands on one, I'm going to test the shit out of it. And then I'll be happy to tell you the truth of what I think about it. But it looks pretty good.
Cool. But the best answer you can give under the circumstances, launched yesterday. And I don't know anyone who's used it clinically yet. So we're all looking forward to that. All right, Jonathan, that was spectacular. As you know, I got to catch a flight, so we slated till 5:45. It's perfect timing. There are no other questions. This was recorded. We'll have it up on our blog section of the site. And Jonathan, where can people find information about your courses, and how do they order the THS caps? Do you have to take your course to take the THS caps, or you're?
You can order whatever you want. There are free YouTube lectures on all of these things, the THS cap, Powerball screw, all of this. But you'll never understand. If you really want to learn, it's like you want the cliff notes, or you really want to learn, because when something goes wrong, you have to be able to understand it. So everything in terms of like the free YouTube lectures and ordering all of my parts and my inventions and my patented stuff is thepowerballscrew.com, thepowerballscrew.com. My online course is amazing. I just re-recorded it. It's got all the latest and greatest innovations in terms of my workflows. And that is at smilesyllabus.com. You can buy it online and watch it at the convenience of your home. And then you get to join our alumni group, and you have all the answers that you need. But no, you no longer need to take the course to buy the parts. But I would say you need to take the course to learn how to use the parts correctly.
Cool. Thank you very much. Thanks everyone for taking time away from your family or the office to watch this webinar. At CADA, we're going to be launching these all over again. Carried us through the pandemic, and it was very popular. So we plan on doing a lot more of these. And I want to thank Jonathan for creating the movement behind this, or giving us the momentum to redo these again. They're very worthwhile. So thanks for your time, everyone.
All right. Thank you so much. Have a safe flight, Armin.